So please try to find the most important key terms of this unit and try to read it for us. Try to find the key terms and label all of them. And we will read them. Please try to find the main part of this unit. We would like to find the main part of this unit and try to find the logic or try to find the reasoning process of this unit of this part. So firstly, we'd like to find the main parts or the main idea of this unit. So try to find each main parts, and we would like to arrange or rearrange all of them for inquiry-based learning. So please try to find the main parts of this unit, and we would like to do that or rearrange the sequence of those parts and conduct inquiry-based learning for our course. So firstly, please try to find the main parts of this unit or the main idea of this unit. We have several main ideas, so we have to try to find them. After that, we would like to rearrange or just follow the sequence of the textbook. But now, we have to try to find the main parts of this unit. So what are they? What are the several main parts of this unit? For example, for me, the first one should be just the structure of the atom, but actually that's truly the unit of this part. So firstly, for me, the first main part should be the consequence of Rutherford's experiment. That's my first main part. But for you, which one? And what are they? What are those several main parts of this unit? How many main parts for you? How many? Yeah. For this unit, actually we could divide this unit into several parts, right? So how many parts? How many parts?
One thing.
How many? Only two?
Let me see again.
Okay, yeah.
Because I just went in here only.
Thank you. So please see that again. So. How many parts?
We'll divide
into
those for experiment and discrete energy.
Only two? Rutherford's results of his experiment and discrete energy. Only two parts? Thank you. So
I will add one part is absorption spectrum.
okay, so you got three parts for Rutherford's experiment, discrete energy
And
absorption spectral. So three parts. Okay, so how many parts?
Maybe four.
Four.
Another one is called links.
Called links. Yeah, so for additional part for link.
Yeah, because we could see that Hubble discovered that the spectral line emitted from distant galaxy show a redshift. I think they would connect it to Earth science, but I'm not pretty sure if they got Earth science or something in the IB lecture.
Yeah, and also maybe we can call that for the several main parts of the one for Rutherford's experiment and also discrete energy Then we have Rutherford's experiment for the first part, and we also have discrete energy. Then after that we will discuss about absorption spectra. So you just said that we actually need a link for Hubble's discovery for a far galaxy's emission spectra, right?
Yes.
Okay, so why we need link? Did you find that? Actually, for Rutherford's experiment, discrete energy and absorption spectra, they are the cases on the Earth, right? They are the cases on the Earth and also in the experiment. They could be controlled by physicists or scientists. But actually for the link case, we just observe the astronomical objects in the sky. Actually, we could not control that for the source of the emission, right? So that could be a kind of application or higher level thinking for the most important part for the 3 parts learning. So that could be a better part for the application for these 3 parts learning, and also for what? Discussion or debate, right? So that could be a kind of debatable question, or that could be a kind of discussion or application part for our learning. So 4 parts, more? How many parts?
4.
4.
Yeah. Or another one for problem solving.
Problem solving.
Simple solving.
Simple solving.
I never work. Yeah.
Okay.
Yeah.
Additional parts for simple solving or word example. Okay. Example. Because all the students have to encounter their future external assessment. Yeah, so example could be another kind of application for the unit of learning. So, Lin Zhen, how do you think about that?
Yeah, work example should be add on this.
Example part. Okay, so we have 1, 2, 3, 4, 5 parts for our learning. Do you agree? Okay, so where on?
I think only
3.
3. Because I think links and example is not the main parts. So
Link.
It's like additional. It's not the main parts.
Okay, so you think there should be 3 parts for, okay, so only Rutherford's experiment, discrete energy, absorption spectra. So they are not the main part. They should be.
They're like the introduction. They
Ah.
for the same idea. They are not the main parts of this unit.
Good. Okay, so since we just find the main parts for the main idea of this unit, next we would like to rearrange or try to determine the sequence of inquiry-based learning for this unit. Try to help us to determine the sequence of those 4, 5, or 3 parts. Please try to determine the sequence of those 4, or those 3, or those 4, 5. Try to find the sequence of those, since actually several students think there should be only 3 parts or 4 parts, even 5 parts. But actually try to find the sequence, because we just want to conduct the inquiry-based learning. Yeah. So which one should be the first one, and following what, then what is the sequence? Or you just want to follow the textbook? Yeah.
Yeah, but according to Weiro, maybe we could put a link
Into
in the first.
in the first.
Yeah, so they could know why they need to learn this.
Okay.
Or how they could apply this.
That's a true cool idea. So
这个
Weiro.
风吗？
But but they don't know the concept of
Spectral or discrete energy.
Yeah, so if we put the links first, they don't know what is the redshifts of the spectrum.
So actually, that could be a kind of skill for if I just put this case firstly, or in the introduction part. What should be the function of that case for Hubble's discovery of the spectra of galaxies? If they don't want, actually for a teacher, we always need to worry about students that doesn't have any background knowledge, so they cannot understand or they cannot discover anything in our class. But actually, if I just put this case before Rutherford's experiment, what should be the function of that part? Since students do not have any background knowledge, right? But several teachers would do that. Since students did not have any background knowledge, but several teachers would do that. They just put the case before any inquiry-based learning for the introduction part. Why? Since students do not have any background knowledge. Motivate or try to engage our students. Try to help them to be curious about what we are doing now. So that could be not the proper question for students. Maybe they just ask that question for engagement, not for the solution of that question, right? We just put that problem firstly. We just want to engage them, try to interest them what we are doing now. But students are not anticipated, not expected to solve that problem. So several teachers would do that. We just put such kind of questions before any kind of inquiry, any kind of teaching. We just want to interest them. We just want to engage all the students with what we are doing now, with what we are studying now. So that could be a kind of sequence. So what would you do? What should be the sequence of your inquiry-based learning for this unit? So please try to think more about that. Or you just want to follow the textbook.
We could start from the example.
Start from example. Okay. Example firstly. So students need to solve that example, or just a kind of question, try to interest them.
Try to tell them this is gonna show up on the exam.
Oh, okay. Yeah, so we just put example firstly.
Yeah, but
Don't forget you got external assessment, so you need to study hard, right?
Asian kids.
Oh, okay, so how do you think about that? Really? We just put the assessment example for students that what we are doing now, you just need to study hard. That could be a difficult problem for you. So please pay attention to what I'm talking about. What?
Not that difficult. Not that difficult.
Not difficult. Okay. So how about you?
I would like to put the link first.
Put the link first.
Yeah.
Just Hubble's discovery.
Because I think it can motivate the students' curiosity.
Motivate the students to be engaged in our class, right? Good. So example could be a kind of idea, and also Hubble's discovery for the link part. Okay, so different idea. How about you? Which one stands for the first part?
I think it's link. Yeah.
Example?
Yeah.
Hubble's discovery?
Cover.
Which one should be the first part of your class, of your unit planning?
Okay, but
You're still thinking.
yeah.
Okay, so
or yeah, maybe.
so please say more later. So Nina, how about you? Since we have 1, 2, 3 main parts of this unit, and also several classmates, they think that they should be link and also example. But now we just want to determine the sequence of inquiry-based learning for our lesson plan. So which one should be the first part of your unit plan? Just like Youjia's idea, he thinks that we should put an example firstly for our student. And also, Junyan said that we should have Hubble's discovery part for students' interest, try to motivate the engagement. So, how about you? Example firstly, why?
Maybe a motivated example can interest students.
Students' motivation. Okay. Try to tell them that don't forget your external assessment. We actually have such kind of test, such kind of question for all of you. After learning this unit, you have to solve such kind of problems. It's not very difficult, very easy for all the students, right? Thank you. So you do agree for example idea. So how about Linzhen? We still have other ideas about not only example firstly or Hubble's discovery firstly, actually for like Zijin said that Rutherford's experiment should be the first part, right? Okay, so.
I think we should put the phenomena in real world.
Put the phenomena firstly.
Yeah.
What phenomena?
The Hubble's discovery.
Oh, Hubble's discovery.
Maybe
Yeah.
the redshift.
We just put Hubble's discovery firstly, then
And tell them why was that?
why we have such kind of results, or why we have such kind of footprint or such kind of something. Okay, so to interest our students.
Yes.
Thank you. Wei Rong. Hubble's Rutherford example.
I will put absorption spectrum first, and then discrete energy, and then Rutherford.
Absorption spectrum firstly,
Yeah.
then discrete energy, then Rutherford's experiment.
And then it's an example. Because I think the student needs to know for one elements they have their own spectrum, and then the redshift is meaningful for them.
Yeah.
So we need to know what is the absolute spectrum, and then tell them there are some redshift from the space.
So, you mean we actually need to help students to understand there should be a kind of absorption spectrum in the world. Then after that, we can help them or instruct them. There should be Hubble's discovery about the galaxy spectra, right?
Yeah. So after we introduce them the absorption spectrum, we can find out there are some concepts of discrete energy, and then why is there a discrete energy? We can find out like from the structure of the atom, and then introduce them the Weber experiment, and then give them some links. It's like, I think.
Yeah, good. So much different sequence from other students. So now, since we have several main parts of unit today, Rutherford experiment, discrete energy absorption spectra, and also Hubble's or example. Now, we would like to determine and actually need to conduct the inquiry-based learning today. So, if I have A, B, C, D, E. Okay, try to determine your sequence and also your corresponding question for your own inquiry-based learning. But actually, before that, don't forget, we actually have such kind of classroom discourse and divide the classroom discourse into two parts, right? We have one for bigs. So another one is someone say that. Kelp, thank you. So big stands for what? For social language in our daily life, just like interpersonal communication, right? For KELP means academic language. So academic language and also interpersonal communication. So now, we always need to arrange or design our classroom discourse for BIGS and also KELP. How can I do? We always need to put BIGS or put our lecturing using more BIGS, right? For what we are saying now, just like, what are your thoughts about that? How do you think about this? And also, think, pay, share. Think about the question, pair up with your neighbor, sitting knee to knee or shoulder to shoulder to discuss about that. They are BIGS for lecturing. So we always need to use more social languages for lecturing. But actually for KELP, we still need to teach academic language for students, right? So how can we do? Where should we put our academic language for students? Since that's just for lecturing or BIGS. So for academic language, we always put them lecture, what I'm doing now. For lecture notes or worksheet or literature, any kind of literature or the slides. Yeah. So try to help our students to listening to the interpersonal communication more. But actually they have to read or learn the academic language for or in the lecture notes or worksheet or slides. That will be more feasible for our class teaching. Okay, so now please try to put your main parts of teaching and also need to determine the sequence of inquiry-based learning. now. So all the peaks should be embedded into your course design. Yeah. So, did you understand?
Yeah.
Yeah. So please. Actually, initially, since you got your own sequence, just like you mean we need Hubble's discovery firstly, but actually, after we determine our first version, maybe you got another idea to rearrange your sequence. So please do, and please try to put the sequence firstly, or we could not understand what should we do. Yeah. Okay, so please put the main parts for the sequence and also put our lecturing languages and also the questions or inquiry-based learning questions for students. Yeah. I actually got a question for all of you. What is the connection of these two parts? And what is the connection of these two parts? What are the connection or what are the links of these two parts? Should they be independent? No. Yeah.
Totally different.
Yes. But actually, should they be independent? Okay, so please. Please struggle for your first version. Yeah. You maybe find some other kinds of better sequence after you're rearranging all the sequence of unit. If a sequence is D, A, B, C, E, should I repeat D again?
Oh, good question. Yeah.
Yeah.
No.
Would you-
I think no.
No.
The D and
D. No.
Because you already introduced it. What?
Already introduced.
Yeah.
But if students got a question, they just want to ask what you are doing now and after A, B, C, E. So they should be very curious why you mentioned about the D part for the introduction. They got a very big question mark after the class. They won't be very happy, right? So should I repeat D again or not?
Or put the D in the final paragraph. Yeah, I don't know. Maybe,
You don't know.
Maybe, yeah.
D or some other kinds of tailored D prime. D prime. Okay. So actually not repeat that again. We just tailored, modify that question and try to remind them. Did you remember we just mentioned about Hubble's discovery? So would you please try to solve that problem using ABC? Do you agree?
Okay, I agree.
Okay.
Yeah.
So please. So Jin, what's your sequence?
ABC.
A, B, C, D.
Maybe E.
Maybe E. But actually, if we do not have enough time, okay, so that should be like this: A, B, C, D. We are not sure. E. Okay.
Maybe like A, B, E, C, D, E.
That would be more.
A, B, E,
C, D.
C, D, E
Yeah.
for 右家.
Example
Okay.
and example. Okay.
A little bit more.
A, B, E, C, D, E. So A, B, E, C, D, E prime, or just E?
Well, of course, it will not be the same topic, the same example. So
Oh, so actually different kinds of example.
yeah.
Oh, yeah.
After we learn A, B, we try to do one example.
Yeah, so that should be
C, D, we learn
A, B,
another
E,
example.
and C, D, E. Right? Okay.
I think this should be connect with C. So my answer will be A, B, C, E, D, or
A, B, C, E, D. More? Only A, B, C, E, D. Okay. A, B, C, E, D. Why? Why E prior to D? That's okay. That's okay for your first version. Please try to put your question, inquiry-based question, firstly, not only the sequence, okay? Yeah.
I think A, B, E, C, D.
A, B,
E, C, D without E. Yeah, A, B, C, D.
A, B,
A, B, A, B, E, C, D.
E,
Yes.
C, D.
Yes.
Just like 右家
Yeah, but without the E.
E, but no,
Yeah,
okay.
because you give an example and D is the intro. Yeah, so
Oh,
you need to give
Yeah,
it,
okay. How about your sequence? A,
A, B, C, D, E.
A, B, C, D, E. Yeah. A, B, C, D, E. That's proposed by Nina. Okay. Lin Zhen is waiting for my cold call, right?
D, A, B, C, D, E.
D, A, B, C, D. D, A, B, C, D. E. Or another kind of color. Or E prime or A, B, C, D, E. Just E. How can I address you? Bella, what? What kind of E? What kind of E? And also
I think she says Lee,
Lee. Oh, sorry.
Lee.
right?
Lee.
Oh, yeah, okay.
Okay.
Very.
Oh, okay, thank you. Not Bella or Bella. Okay. Yeah, so. Yes. We got several versions now, but actually we have to put the inquiry-based question for students. After that, we can teach our students, right? So please do that. And now, if you got your first version, you do understand what we are doing now, then maybe you could rearrange your sequence or rearrange your course design. Yeah, so let's take a break. So think more about that. If you did not have your breakfast. So please go for your breakfast or drink a cup of coffee. Okay, so now if I just follow which version? A firstly or D firstly? Well, just follow A, B, C, D, E for our first version. Okay? Yeah, so now, firstly, I just put Rutherford's experiment. Telling what? Telling the structure of the atom. So, what should be the question and what should be the context for students? What should be the context and what should be the question for students? Actually, we got two pictures for students, right? Firstly, we got this one. Since we don't know what is inside, but actually we got a lot of alpha particles penetrating, but several of them, we got a very large angle scattering for the unknown material structure. So that's first context for students. Now, should we provide the apparatus experimental setup for students? Should we put that? Okay, should we tell students that how can we conduct this experiment? Like the picture here, we actually have the source and sample impinging onto the sample. Then we get the scattering angle here. My question is, should I put this? Or we only need this one? Should I put this for students?
Both?
Both?
Yeah, because that's a zooming picture of.
Yeah. So should I put this together?
Sure.
Sure.
Yeah, why not?
Yeah, why not? Okay. So what's the question for students? For the first part, or for part A, what should be our questions for students? We actually have two ways for it. We just put the questions for students. But if we do not have any idea, what can we do? We just try to find the answer firstly. Since we have answer, try to find the question corresponding to the answer. So since we have answer, try to find the corresponding questions. Sometimes it could be a little bit easier, right? So what should be your way?
If the result of the experiment is recognized and
shown here.
what do you think?
What do you think? Okay. What do you think? What do you think?
What is the structure?
What is the structure inside the material? So, what do you think is not the key part? What do you think is just the peaks, right? So what do you think? We don't need this part. So that should be, what is the structure inside the material? What is the structure inside the material? Is that enough? Or is that easy enough for students? What's the structure? Inside the material. For first question. Or actually, you still need more questions. Do you have more questions?
I only think that.
Oh, okay, only this one. More? If I provide these results or this picture and ask a student, what's the structure inside the material?
The structure inside maybe is some how to say it?
Shall I tell students that alpha particle is positively charged?
Yes.
Yes.
Yeah.
Shall I provide this?
Yeah.
So
because just okay. You can.
Okay, so the alpha particle is, or R, is positively charged. Okay. So before this question, we just provide, well, alpha particle is positively charged. So since we have these results, what is the structure inside the material? Is it enough for students to get the structure of the atom?
I think no.
No, thank you.
Because student might draw like this.
Please.
Yeah, because here we could only see that some particle will penetrate, some will rotate. So maybe the student will draw like this. Alright, a circle, and here is the positive one, and other parts is the negative one. Yeah, but this is not an atom structure.
Right? Since we have periodical structure for same kind of atom, we actually can get the same results, right? So how can we help students to understand what is the structure of the atom? Or can we provide several possibilities for students for matching, for choices? Can we do that? We just provide several kinds of possibility, several kinds of choices for them. So if I got in such kind of open-ended question, what is the structure inside the material? Actually, students could have a lot of kinds of different imagination. But actually, we could have another kinds of choice for provide several kinds of different choices for students. Then ask them, please vote for these three kinds of possibility. What should be the structure of the matter inside, or structure of the atom? What would you do? Firstly, for open-ended question. Second, provide several kinds of version for the interpretation. What would you do? So, two kinds of choices for you. Now, please raise your hand. Firstly, for open-ended question, please raise your hand. No? For maybe 2 or 3 kinds of possibilities for students, would you do that? Thank you. But actually, Lin Zhen. Oh, you provide several choices for students?
Maybe I will ask another question. Like compared to the model they have learned.
So you just provide this model, or provide other kinds of like pudding model.
Thompson model.
Yeah. So you got alternative way, not only provide several kinds of choices. So would you please stand here to depict your picture for them to say more about this, please.
Because they have learned Thompson model.
Thompson model
So.
and Rutherford model.
Thompson model is one of the choice.
Oh, okay. So We got
Okay.
Thomson model and Rutherford model. So you got two kinds of interpretation for the results here, and help students to choose or vote them. Okay. So we got A and B for students to try to help them or instruct them to answer that. So what is your question and what is your directives now? So that should be, what is the structure inside the material, A or B? Will you do this or not?
Yes.
Yes. So for first question is, what's the structure inside the material, A or B? But before that, we should provide this information for students that alpha particle is positively charged. Since we know alpha particle here is positively charged. So now, what is the structure inside the material, A or B? Is that enough?
And you should also ask why, and why the other options we could not explain them.
Why what?
Why you choose this?
Oh, okay. A or B? Why? Okay, so for students, why? Why is not a very easy question for students. Can we got a more structured way? Or only just put why? After A or B? Ask why? Or
Maybe we can provide the Thomson model and Rutherford model and let the students draw the alpha particle path. Yeah, and how the
alpha particle will penetrate or go passing the atom.
Yeah.
Oh,
Let them draw the path.
so your way is, what's the structure inside the material, A or B? Then we provide those two different kinds of model for students. So please try to predict. When it comes to alpha particle positively charged going through the material, what would happen for Thomson model and also Rutherford model? Oh, so do you agree? I just put down that. What would happen? What would happen when alpha particle particles go through the Thomson and Rutherford model, right? Okay.
I think is for
Yeah.
The second, this one.
Yes.
Maybe it's the correct one.
Yeah, of course we do understand, but my question is, if I want to help students to construct that by themselves, what should we do?
Oh.
Yeah, so
Now-
Julian just said that we just ask students to say that what would happen when alpha particles go through the Thomson and Rutherford model, right?
Yeah.
Yeah.
So drawing the picture with between two models and explain how to modify it in different model, why the particle is growthful, just like the Rutherford is growthful here.
Yeah.
Yeah.
Yes.
And Thomson just slide on it. Yes.
Yeah. Yeah. But actually, for me,
Yeah.
my question is, should I provide more information about Thomson model and Rutherford model for students?
I think yes.
Yes.
because Without those basic knowledge, they will not able to answer this question.
Yeah. Yes.
They don't know what is the difference between those two and what is Thomson model and also what is Rutherford
Yeah.
model, right?
Or
Yeah.
maybe they do.
They,
I'm not pretty sure. I'm not pretty sure.
Yeah. Maybe we just need to first pronounce to tell them what is Thomson models and Rutherford.
what is
这国中有，这现在国中课本还有。
Thomson model and Rutherford model?
Yeah.
我记得
我记得我那时候国中只学到 Rutherford model。
我也忘了。
好。
我好像是 Rutherford 比较多一点。
Actually, since you did not remember that, so that just means we have to provide those information for students, right?
So yeah, so need to introduce which to these two informations and
Okay.
yeah, between what is the difference in these two first.
So before this question, what is the structure inside the material A or B? Before that, we actually need to provide the information of Thomson and Rutherford model, right? Do you agree, Nina? Yeah, thank you. So, for that's just part A. At the end of part A, students need to understand we actually have a structure of an atom. We have a so tiny part for nuclei or nuclear and electron around the nucleus of an atom. And also, most of the space are actually not occupied by electrons. Yeah, empty. They should be empty for most of the space, not just part A. For part B and C, I think part B and C should be the most important part for this lesson or for this unit, right? So I will put down B and also C. So what is B? B is
Model, yeah.
B. Part B.
Part B. Alright.
Okay, alright.
Discrete,
Discrete energy.
yeah. Discrete energy. And C is
C is the
Absorption.
spectrum.
absorption spectral. Spectral.
SP is
Spectral. Okay. So there should be a very strong connection of these two parts.
Yes.
So which one is prior to other? What would you do? And what information would you provide for students saying, what is your inquiry-based question?
I would say these two units come up together. There's no priority of these two.
Good. So what should be the first picture, first information, first evidence or first data for students?
Photovoltaic effects.
Photovoltaic.
Effect.
Photovoltaic?
You know the Einstein?
Einstein?
Einstein. Try to.
I know. I know what you mean. Photovoltaic or photoelectric effect?
Wait,
Here?
I did. Electric, photoelectric.
For this unit, we just
We need to talk about the energy,
yeah.
right?
Yeah, we just talk about the absorption spectra of the atom, and also discrete energy of the atom, not photoelectric effect.
I mean, but how can we tell students about because here we're going to talk about electrons.
Yes.
I think photoelectric effect is not necessary for atomic negative
Yeah.
structure.
Yeah.
Yes. Yeah. So we just want to talk about the transition for the energy levels of an atom, just for this unit. Okay. Photovoltaic or photoelectric effect is the next chapter in the next unit. Yeah. Yeah. For quantum physics. Okay. So we only discuss about the spectra of an atom or the absorption spectra of atom corresponding to the structure of the atom. Okay? Only the atom. Yes. So please, which one is prior to another one? Or what should be the first part? Emission spectrum firstly.
Yeah.
Okay.
Actually, I have
Emission spectrum. So, which diagram? Which diagram?
there's a thought of we should talk about absorption first.
Absorption.
because you know why? Because the electron must be absorbed and photon first, then it will emit.
Okay.
So that means that in this case we should talk about absorption first.
Absorption first.
Then we should talk about the
So which diagram? Figure 21.6.
Figure 21.5.
Figure 21.5.
5.
21.5. 0.5?
8.5.
Figure 1.
You have a model.
0.5 is a model. Should we put model firstly or put the evidence firstly?
Well, for inquiry-based learning,
Yeah.
maybe it's the evidence first.
Thank you.
But we can also start from the theory.
Of course.
Then predict.
Yes, of course. Yeah, inquiry-based learning is not strongly connected to, well, inductive or deductive learning. That's not important. But actually, for students, they may, if they just play the role of scientists, they have to, and what? They have to face to the evidence firstly, most of the case. Okay, so emission spectra or absorption spectra firstly. Yeah, but actually, when the scientists study this part, they do not have any model. They only have what? They only have discrete energy. Yeah, corresponding to discrete wavelengths. They only have those information. Actually, for the spectrum of emission or absorption parts， 就他们其实就只有这个东西而已。对，那其实当初就已经这样就把公式给凑出来了，凑完以后才有波尔的原子模型硬要解释，然后才对上那些东西。这样，所以其实我们这一段搞不好只需要去把这个能量对应这个波长，跟这个能量对应这个波长的关系，帮助学生找到，很有可能就完成这一段的任务。然后其他就让学生再回来解释，就是我们就提供这件事情给学生。对。
So student must know the EK diagram, right?
Yeah.
Y-axis means the energy.
Yeah.
X-axis means nothing here, but it should be represented to a k-space.
Yeah.
Okay, good.
So how can we do? 就这一堂课最精华的地方，应该就是这一段而已。就是这一段，我们如何让它去做这个对应这个？我们来看一下 check yourself for. Check yourself for. Let's look at the question. Which one results in the emission of a photon with the largest wavelength? 你看到它就是希望让学员去知道，原来就是这个能量差去造成。那最后再把这个 model 去对应到原来原子结构上面的能阶是这样的，但一开始他必须要对这件事情先有感受，他知道 wavelength corresponds to the energy difference. Okay. But firstly, or originally, physicists, they don't know what are they. They just know there should be some kind of mathematical formula, some kind of mathematical relationship between them or among both of them. So how would you do? Since if we have those information, what would you do?
Like, what should we tell them or what activity?
Of course, we can tell them.
Yeah, we can tell them.
And of course, we can.
Means the energy.
Yeah.
Maybe the students to guess.
To guess, good.
To predict. Something like that.
Or maybe we just put some simple formula or simple results, some simple results to help them to find what happened here. 我们是不是有这几个能量，对不对？我们可不可以拿这些能量？我不需要让他这样一看说，哎，你的数学之神来帮我找一下你这之间的关系到底是什么？不用，我们可不可以把某些东西丢进来，让他们去发现？比方说，我们偷偷的暗示，这个可能是。就是用这种方法来帮助学生找到这些东西的关系。对。
或者是，或者说直接写，我们应该可以用更高层次的问题。
可以来。或者填表格可以吗？就我们下面造一个表格让他填，然后把他们之间的关系找到。就是课本已经有这几个算法出来了，但我们要把这些事情再整理到它最后跟这个公式是有密切关系的。那我们要怎么放一个表格来帮助他把这件事情给建构出来 ？What can we do？ 这是一种方法，用数学方法嘛。课本里面画个图是这样画的，大家有注意到吗 ？Let's look at figure what? Figure 21.4. Yeah, 21.4. For this one corresponds to n equals 1, right? 3.4 corresponds to n equals 2. And 1.5 corresponds to n equals 3 and in n equals 4. Of course, we can provide that for students. That's just a semi-model for student. 我们就提供一个半模型给他，就是这个感觉好像我在教他了，可是我可以提供一半给他，让他依循着这个半模型把某些东西找出来。这另外一种方法，所以我不见得一定要从头开始让他建构，可是我也可以走到一半，突然间先给你一点辅助，让你从这个模型来想某些东西。所以，我可以怎么做？
I think we can also provide another information about the energy of the spectrum.
Yeah.
So they can find and ask them to find the relation between these two information.
Yes. So, what can we do? We just provide.
Yeah, we just provide the energy spectra of the emission spectrum.
Yeah, provide energy.
Yeah.
So they can convert. They can get the conversion of this part and those parts.
Yeah.
Right?
Yeah.
Yeah. 就是我们现在就提供真正的真实能量或波长给他。我们提供能量或波长都可以嘛？对吗？哈，就是然后让他来换算。当然，能量是比较直接啦，或者我帮他把能量换算好，就是yeah. According to the results of the spectra, we actually detect the lambda wavelength, not the energy, right?
Yes.
So we actually can help students to get the conversion of lambda into energy. Firstly, 我们帮他换算好，就比方说我在这里换给他看，告诉他说635。
E 等于 HF， 然后我觉得怪怪的。怎么这是 C 等于
That's really cool. Thank you. H nu or HF. So like this, we just provide the wavelength here, then we can get wavelength here, then we can get the energy corresponds to these parts. So lambda into frequency and then into energy. That could help students to find the relationship among all those parameters, right? So, what's your concrete question? 可以直接给我具体的做法吗？
find the relationship between these two formations.
Yeah. 我的意思是说，可以给我这里大家预计要放的能量或者波长吗？
I think you can put the energy.
You put the energy.
Energy. Difference of energy level.
Okay.
Like the.
Like
difference.
1, 2.
Yeah.
So
Difference. Give like 10.2.
10.2 electron volt.
Yes.
Okay, so those two,
Yes.
that should be,
Should be
so those two,
0.64.
0.64 electron volt. Okay, so you provide this or wavelength here.
No, I think we can only just put the
Table,
the spectra.
the spectra,
So we can say that.
and put wavelength, only wavelength.
I think so.
Yeah.
Yes. Yes.
Okay, so we just provide wavelength for students here.
Yeah.
So should I put the energy simultaneously or not? Simultaneously. We just provide energy wavelength here and energy simultaneously put on the table. Then, okay, so we just provide the full table for students to ask them what should be the relationship among those. Okay.
Kind of like a math question. Yeah. They need to find the difference.
Yeah. Yes. So how do you think about that?
I think that is interesting. True.
So we just provide this diagram and also this table.
Yes.
Yeah. Then what should be found by students?
They will find the right hand side, energy on the right hand side is the difference of the left hand side.
Okay,
So we can tell that we can define the left hand side and use that.
good. So what is your question like this? What is your question?
Find the relationship.
Find the relationship. Okay, I will put down that. Find the ship
Between two blocks of energy.
among or find the relationship
Between
between or among.
among
Between, if we only have two parts, we just use between.
Yeah.
But actually, if I have more parameters, we use among, right?
I think yes, between.
Between. Okay, only two. Okay.
Yeah, we want to talk about two levels.
Between
Two blocks of energy.
two
Block of energy.
block of
Or
Two.
volume. No. Two cold.
two rows, too close, or two neighbor.
No.
No,
I mean this.
this column.
Yeah, the column. Yeah, two
Oh.
columns of energy.
Two column. Two columns of energy, or two data stream
Oh, data stream. Yes.
of energy. Two data streams of energy. Find the relationship between two data streams of energy. Then,
Then after they find out, we can start our lecture.
okay. So after they found the energy, what should we do?
We can model the energy data.
Provide this model,
Yeah.
or ask them to interpret, or ask them to provide this one. What would you do?
They pick a diagram to show the relationship.
Or what information should be shown on this diagram? For example, for the first one, we just provide the most simple diagram, just like this. Or should I put this kind of diagram and tell them that actually the energy difference of these two is 3 to 1.89, right? We just tell them that should be. And also tell students that for this is what? 1, 2, 3. 1, 2, 3. We should add those two, right? So that should be 12.19, right? Those two for 3 to 1. What is the energy difference? 12 point
Yeah, 09.
09. 12.09 electron volt. That's another way we provide this kind of energy difference between for them. What would you do? Provide this simple diagram for them, or just provide this diagram including the energy difference? What would you do?
I think we can just let them to depict themselves. It's just
To depict themselves, all the diagram or part of the diagram?
all the diagram.
All the diagram.
Just a way of interpretation of this information.
Okay, that's enough for students to interpret that. So, do you agree? Agree. You do agree. So how about Nina? If we just provide those information for students to help students to construct this diagram for themselves. Is that possible? Since if you were a high school student, the teacher just provide this.
High school they can pair with each other and discuss.
Good.
What if they just, look up the textbook or twice in the bottom?
It's okay.
Yeah. OK. 好，这是其中一种方法啦。但是要讲的事情是刚好中文想，所以下礼拜的第3节要上去上的人是右家。
我上到哪里？
就这个小节上完就可以。